M.S. Ramaiah University of Applied Sciences.
Hi students, let us discuss calibration of micrometer. Comparison between a known measurement and the measurement as obtained by a measuring instrument is called calibration. Micrometer, also known as screw gauge, a measuring instrument which makes use of a calibrated screw for precise measurement of components. Derives its name from the two Greek words micros means small and metron means measure. Used to measure dimensions like external diameter and thickness of a component. Reading a micrometer with standard scale. Least count 0.01 millimeter. Measurements from the micrometer is summation of readings from sleeve scale and vernier scale. Here, sleeve scale reading 7 mm and thimble scale reading plus 0.37 mm. Total micrometer reading is 7.37 mm. The accuracy of a micrometer is derived from several factors. The most significant factors are thread accuracy, flatness of measuring faces, parallelism between the faces, rigidity of the frame which holds the anvil and spindle. We are using IS 2967-1983 Indian Standard for calibration of the micrometer with range of 0 to 25 mm and least count of 0.01 mm. As per the standard slip gauge are rung to the known dimensions and measurements are recorded. The trials are repeated for 3 times and average measurement is computed. Also, each measurement is compared with allowable error as per the standard. If the error is more than allowable limit, then compensation must be recommended. Standard versus measured and standard versus error graphs are plotted after the calibration is completed.
Hi students, the next experiment is calibration of micrometer using slip gauges. The aim of the experiment is to calibrate the micrometer using slip gauge box. The apparatus required for this experiment are the micrometer. This is the micrometer which you are seeing. The range of the micrometer is 0 to 25 mm. The least count is 0.01 mm. Now let us understand the different parts of the micrometer. The first part of the micrometer is the frame. So this is the frame, the anvil, the spindle, the sleeve clamp, the sleeve scale, the coinciding scale, the thimble, the ratchet and the fiducial line, the center line which you are seeing here. The micrometer holding stand. This is the micrometer holding stand. Between these two jars, micrometer will be held for calibration and even for measurements. This is the clamp adjusting nut or knob. This is the positioning adjusting knob. The slip gauge set box. This is the standard slip gauge set box which is having 88 different slip gauges of standard dimensions. Now let us start the experiment. The first step in this experiment is to do a visual inspection of the instrument or the micrometer and see that all parts are working and are in good condition. The next step is to see that whether the instrument is having any zero error. I am rotating the thimble to the home position. I have reached the home position. I am rotating the ratchet 3 times and I am locking the spindle clamp. Now one can see a good match between the thimble scale and the sleeve scale. This is the sleeve scale, this is the thimble scale. The 0, 0, you can see a good match between the fluid line and the 0 of the thimble scale. Now let us mount the micrometer on the micrometer holding stand. Make sure the micrometer is held properly between the jaws of the stand. Now we are going to use IS 2967-1983 standards for calibrating the micrometer. The standard measurements for which the slip gauges are to be run are given in the table. The maximum permissible error is 2 micrometer for this calibration procedure. The first standard measurement that has to be measured using the micrometer is 7.7 mm. In order to get 7.7 mm, we are going to ring slip gauges. The first slip gauge is 6.5 mm, next 1.2 mm slip gauge. So 6.5 plus 1.2 will give you 7.7 mm of standard length that has to be measured using the micrometer. Now I am taking 6.5 slip gauge and 1.2 slip gauge. Now let us clean the surfaces of the slip gauge using a clean cotton cloth. I am removing the grease . Similarly, I am cleaning the 1.2 slip gauge. Now let us ring the 1.2 slip gauge to 6.5 slip gauge. So this is the initial position. I am gently applying the force. Now we have 2 slip gauges run and they are measuring 7.7 mm. So this is the standard which we are measuring in the micrometer and finding out the error. Now let us measure the 7.7 mm slip gauge set in the micrometer. I am moving the spindle backwards. Now I am moving the spindle forward. 1, 2, 3 and I am locking the spindle clamp. Now let us record the measurement. So in this sleeve scale we can see up to 7 mm and 0.5. On the thimble scale we can see that the 20 is crossed and the center line is between 20 and 21. Now the reading is 7.708 mm. This is about 6 micrometers more than the expected or allowable limit as per the standards. Similarly, measurements will be taken at 3 different locations on the slip gauge. The first location we took at the center. Now we are taking at the lower end. Similarly, on the upper end of the slip gauge, we can record the measurements. and finally we can take the average of the reading and compare the average reading with the allowable limit. The next set of standard measurements as per the standard is 10.3. So in order to get 10.3, let us choose 9 mm slip gauge and 1.3 mm slip gauge and ring both the slip gauges so that we can get 10.3 standard length for calibration. Now I am picking up 9 mm slip gauge and 1.3 mm slip gauge and cleaning the surfaces so that I can ring both the slip gauges to form 10.3 mm. So I am cleaning and removing the grease from the slip gauge. Now let us ring the slip gauges. Now we have 10.3 mm slip gauge as a standard length. Now let us measure the 10.3 standard slip gauge set. Now you can see the error in the measurement. The measured value is 10.308, which is 6 micrometer more than the allowable limit. Similarly, let us measure the slip gauges at the other two ends. The center position and the upper position. Now you can see 10.302 reading. Once this is done, the next step is to tabulate the readings and find out the average measurement of the slip gauges and compare that with the allowable limit. Similarly, one has to complete the calibration by measuring different standard lengths of 12.9, 15, 17.6, 20.2, 22.8 and 25 mm and find out the average reading and compare the average reading with the allowable limit. So this completes the calibration procedure.